welcome to Unit 7. Unit only has 2 lessons in it. This first one will be dealing with sequences, and the second one will be dealing with series. All right, so let's get started. Okay, so a sequence is pretty much just an ordered list that follows a set pattern. So if we're talking about a sequence of numbers, it's something that has a pattern. All right, and there's 2 different types we're going to talk about, arithmetic and geometric. And it's just, the difference is how you get from one number to the next. So in an arithmetic sequence, you have what's called a common difference, meaning you're adding the same number between, to go from one to the next. And we want to always think in terms of addition, okay? And I'll show you what I mean in a second. But when we look at this first example, our pattern goes 2, 4, 6, 8, 10, 12. So we know, after learning about number sense, that means that we're counting by twos. Sorry, had to reach over and get something. Anyways, okay, so our common difference is 2 because the numbers are increasing by 2. So that's what I'm adding to go from one number to the next. 2 plus 2 is 4, plus 2 is 6, etc. In this next pattern, I'm going 10, 4, blah, blah, blah. So you can see my numbers are getting smaller. So my common difference is -6 because I'm still adding, but since they're getting smaller, I'm adding a negative. So an arithmetic sequence has a common difference. You're adding the same number to go from one pattern term to the next. A geometric has what's called a common ratio, meaning you're multiplying the same number each time. And it's important to always think in terms of multiplication, not division. We'll look at that in one second. So at our first example, my pattern goes 1, 2, 4, 8, blah, blah, blah. So my common ratio is 2 because to get from one number to the next, I'm multiplying by 2. My next one, you'll notice my numbers are getting smaller. So that doesn't necessarily indicate a negative, but it means that my ratio is a fraction between -1 and +1. It's a fraction that when I multiply, my numbers get smaller. Okay, so we don't want to think divide by 3. We want to think, what are we multiplying by? Here it's 1/3. Now in a geometric sequence, if you're having a tough time, because sometimes you're given just the fraction part of it, and you're like, I don't know what I'm multiplying by. Pick any 2 numbers in the sequence and divide backwards. So like if you did 4/27 divided by 4/9, you would get the 1/3. Okay, so that can give you your common ratio if you're having trouble identifying what that magical number is. All right, so let's just start off real basic and make sure we know how to identify the difference. So looking at this first pattern, my numbers are going 5, 10, 15, 20, and you can see the dots are implying that it's continuing on in that pattern. Okay, so this is an arithmetic. And I'm asked to list my common difference, which is 5 because I'm adding 5 each time. All right, and so the next few numbers would be 25, 30, and 35. All right, sorry if my numbers look a little funny. I have to keep the headset plugged in because the battery's low, so I have to sit at the computer to do this, so I'm using the mouse. Okay, my next one, 2, 1, 1/2. So you can tell because I'm not adding. Like to go from 2 to 1, I'd have to add a -1. But if I added a -1 again, I would get to 0, not 1/2. So right there, that tells me, whoops, just kidding. That's not arithmetic. It's geometric. And I'm multiplying by 1/2. Okay, so my next numbers would be 1/16 because I just multiplied by 1/2. 1/32, 1/64, and we could keep going if we wanted to, but we don't need to. Good. All right, same thing, arithmetic or geometric. Well, to go from 3 to 6, I would add 3, but if I added 3, I would not end up at 12, which tells me that's a geometric pattern. Okay, so what's my constant, my common ratio here? It's 2. I'm multiplying by 2 each time, excuse me. So my next numbers are 48, 96, and 192. And then the last one is arithmetic. This time my numbers are going down, so I'm adding a -3. Okay, which brings me to -1, -4, and -7. Okay, now what we're going to be doing with our patterns is there's a whole bunch of formulas. This unit is very formula based, and we're going to be answering questions and word problems and all that good stuff. So let's skip the next page. We'll come back to that, but let's go ahead and let's figure out what these formulas are. Let's understand what's going on with them. Okay, so there's 8 formulas total you'll learn this unit. You will have a formula sheet provided for quizzes, tests, SOL, whatever. So you don't need to memorize them. You simply need to know how to use them, which in itself, we got to do a little bit of work and practice with. So we're going to take a look at 4 in this first video. Okay, we're going to look at our recursive and our explicit formula. 1 each for arithmetic and 1 each for geometric. So that will give us our 4 total. Okay, so it tells us the nth term of a sequence, nth meaning any, is written as a sub n. Okay, so if I'm asking you to find the 10th term, you would see a sub 10. Okay, that little number tells you which number in the pattern or in the sequence that we are looking at. All right, so let's start with our recursive formula. It says a recursive formula is a rule that defines a new term based on the previous terms, meaning in order to find the next number in the pattern, you have to know what the previous number is before that. If I want you to find me the 20th number in the pattern, I would have to know 1 through 19 in order to identify that. When we get down to the explicit formula, this one's more helpful because I could instantly get that 20th number without knowing the other ones before that. So that's kind of our major difference, okay? The recursive formula is not really a formula. I kind of don't like that word because we're not plugging things in to simplify. All it does is it gives us information. It's kind of like a wealth of knowledge. All right, so let's take a look. So our example says to get the nth term of a sequence, here's our pattern. We can use this rule. What are we doing each time? We are adding 3. That's our common difference. So when we look at the recursive formula, okay, look down here. This tells us a sub n minus 1 refers to the previous term. So if I'm saying, hey, find the next term, this is all it's saying is take that term before and add the common difference, okay? So if in my pattern up here, I'm saying, hey, find out what the second term is, all it's saying is take the first term and add 3, which is 5. To get the next one, take that term, the 5, add 3, which is 8. And then to get the next one, take the 8 and add 3. So you got to keep going. Okay, so if I look down here, this is how we write our recursive formula. It's always kind of in 2 parts, where this first part is identifying to you what that first number is. Here's where I'm starting. We are starting at 12. And then here's the rule right here, minus 6. Because remember, all this is the fancy way of saying, hey, to find the second number, take 12 and subtract 6. Woohoo, we did that and we got 6. And then to find the next pattern, saying, hey, take that new number 6 and subtract 6. Woohoo, I got 0, etc. Okay, so this first line gives us the first number. The second line gives us the rule. And all this other stuff is just fancy notation that you just got to write in there. This back here, all that's saying is, okay, I gave you the first term, so now follow the pattern of subtracting 6 for the second term, the third term, the fourth term. That's it. It's just fancy stuff that we write out, okay? You're going to see it, so I want to make sure you know what it means. The only 2 pieces of information we really care about are this, the first number, this, the rule. The rest is just fancy stuff. All right, same thing for geometric, okay? First number in my pattern is 12, and my rule is times 1/3. The rest is my fancy stuff. This is saying, hey, to get the next number, take the 12 and multiply by 1/3. And we did, we got 4. To get the next number, take that 4 and multiply by 1/3. And we did, blah, blah, blah. Okay, so recursive formula is not something we ever actually plug something into. It's something that we take information from. We take the first number in our pattern and we take the rule. Whether it's arithmetic, we're adding something, or it's geometric, we're multiplying. The explicit formulas, this is where all the good stuff is. We're going to be using these pretty much the rest of the day and in the series notes as well. The explicit formulas are money, okay? So what it does for us, it tells us that you plug in any number into n to get that term. So if I'm saying, hey, here's my pattern, find me the 100th number in the pattern, you don't have to write out all first 99 numbers. That would be just crazy, okay? So we're going to use this rule. So here's our pattern right here. All this is saying is to find whatever number I'm asking you to find, plug in the first number, whatever number, the 20th, whatever, and the common difference, okay? So if you look at this pattern down here, our first number in the pattern is 15. Okay, that's our first number. And then our common difference is -5. Now, sometimes you'll see the -5 written in front. I prefer it that way, but it doesn't always show up, so just a heads up. I like to write it like this. I just think it looks neater. And by neat, I mean like cleaner, not like neat as in cool. But I guess we could say that definition as well. Commutative property, multiplication, move that in front, same thing. Okay, so anyways, my pattern would be 15, and I could add a -5 each time and go down. Now, what if I asked you to find me the 50th number in this pattern? You don't want to have to write out 50 numbers. So what we can do is we can substitute 50 in for n. So we're finding a sub 50, because I'm just identifying here, hey, this is a 50th term. I'm going to plug the 50 in for n, and I'm going to do math. I know, weird. Times a -5. Sorry, remember I'm writing on my mouse. Okay, so then we go ahead and we do math. So we're doing 49 times -5, and I'm adding 15. So the 50th number in the pattern is -230. Okay, so that's where explicit formula actually is a formula. I'm plugging numbers in and I'm evaluating it to get an answer. Versus recursive, I'm not. I mean, you kind of are, but you're doing it every single time, so you're not really. All right, so explicit, much nicer. I can actually do math. Now, you can use this to find anything. You can find out the nth number in the pattern. We can know the first number and maybe like the last term and find out the common difference. we could find the first number knowing the other pieces of information. So as long as you know, only one piece of the puzzle is missing, you can use a formula to solve for anything, just like in any formula. Yes. All right, so let's look at it for our explicit for geometric, same thing, first number ratio. So those are the only two pieces of info you need, are the first term and the common difference or the common ratio, and you can write a formula. And then to evaluate it, you need to know what pattern we're looking for. All right, so for this one down here, 5 is my first number in the pattern. My common ratio is 2. The common ratio is always the one next to the n minus 1, okay? So if I said find me the 10th number, I'm not going to go too big here because in a geometric, you're growing exponentially. Look how big my numbers are getting quickly. So if I do 5 times 2 to the 10 minus 1, which is really just 2 to the 9th power. Now be careful of your order of operations. The 2, the ratio has the exponent. You cannot multiply this 5 and 2 first. That would break your order of operations. Dear Aunt Sally would not be cool with that. So when I do the math, the 10th term in this pattern is 2,560. Okay, I just simplified that. I did 5 times 2 to the 9th. Good. All right, so we are going to use these formulas. And if you want to pause the video and pop over to my website and download the formula sheet, you then at least have all of them right in front of you so you don't have to keep flipping back and forth, okay, because that can get a little bit of a pain. So let's practice writing these formulas, all right, and then we'll actually use them. So our directions, we're on page 4 now, says write a recursive and an explicit formula for each. Okay, so for the recursive, all we're going to do is we're going to list out the first term, which is 3, and then we're going to list out the rule. Now all this stuff right here, I'm going to be honest, sometimes I forget what to put. So I just go back to my formula sheet and I write down all the fancy jargon right here. All right, main point, common difference, plus 4. Okay, so here's my recursive formula. And you can put the fancy brackets, not very good at drawing those, on the outside. Okay, now my explicit, same thing, go refer to your formula sheet. You're not expected to memorize these. You just need to know what to fill in. So when I'm writing my generic formula, I'm filling in the first number and the common difference, and that's it. I'm not evaluating right now. I'm not finding a specific number in the pattern, so I don't need to substitute anything in for n. Okay, that's a -1. Hard to tell, I know. And that's my explicit formula. That's all I'm doing. I'm just writing the formula. All right, down here it's geometric because I see them multiplying. Okay, so let's first figure out our ratio, and it's 1/5. Now, if you weren't sure, work backwards. Do 3 divided by 15, and you'll get the 1/5, okay? So for recursive, I write it as 2 lines. I write my first number is 15. Okay, and then my second line, I'm saying, okay, take that ratio, which we decided was 1/5, and multiply it times a sub n minus 1. So that's saying to get the next number, just multiply it by that. And then fancy brackets. Yep. And then my explicit formula, same number, first number in the pattern, which is 15. Now put your ratio in parentheses, please, especially if it's a fraction or especially if it's a negative, times n minus 1. Okay, and those are just my 2 formulas. All right, so I want you to go ahead and pause the video and write out 12 and 14 on your own is good practice. Please pause. Alrighty, and take a look. Okay, so in this first one, my first number is 13, which you see both here and here. My common difference is a -6. Okay, and that's all I'm filling in. This one is geometric. My first number was 8. And my common difference, common ratio is -1/2. Notice when it's alternating positive, negative, you know your ratio is going to be a negative value. All right, so let's just start answering some problems now. How are we going to see this? What are we going to use it for? Blah, blah, blah. All right, so question says, what are the first 5 terms? Well, what's the first number? It's 25. It's always this number here. And then what's my common difference? It's 10. I can tell this is arithmetic and not geometric because of the formula. There's not an exponent. If you'll see in 16, there is, so that's a geometric. So if I'm going to write out my first 5 terms, I'm just adding 10. I can just do it by hand. I don't need to use a formula. Just add 10. We're good at that. Now it says, what's the 11th term? Since it's not asking me too far in, I could theoretically write out 11 terms, no problem. Or I can use my formula, just substitute 11 in for n. So I'm doing plus 11 minus 1 times 10. Okay, so 10 times 10 is 100. Add the 25. 125 is my 11th term. Okay. All right, this one, 2 is the first number. And 3 is the ratio. As long as this is n minus 1, that's your first number. And we'll talk about what to do in a little bit in case that doesn't happen. So 2 and multiply by 3. So 6, 18, 54 and 162, I believe. Yes. Okay. Ninth number. Okay. So I'm just going to do 2 times 3 to the 9 minus 1, or 2 times 3 to the 8th. Right? And that's 3 to the 8th. That's not 6 to the 8th. 3 to the 8th times 2. So we get 13,122. Not uncommon. I mean, it's very common that your geometric, as long as your, ratio is a whole number, especially something like 3, you're growing exponentially. So don't freak out if your numbers get really big, or if your ratio is a fraction, if they start to get smaller. All right, so this is given to me in my recursive formula, which is fine. I just need information. I'm starting at 12, and I'm subtracting 6. Now notice in this one, I'm not asking you to identify a specific number in the pattern, because in order to do that, I need to know everything else in front. Like I'm not saying, hey, find the 20th one here. I would have to count them out. Or I could I could take these two pieces of information, write the explicit like this, and then plug in the n. You can totally do that. All right, now looking at number 18, it looks a little bit different. I'm not identifying what the first and last number is, so what do? Remember, n represents whatever number in the pattern you're looking for, so I can just plug 1 in for n and do the math to find the first number. So 1 minus 1 is 0, times 1 is 0. Now to find the second number in the pattern, I can plug in 2 for n. So I'm using the explicit here. It's just not clear what my pattern is. So I'm just going to do math here, which is 2. I can plug 3 in for n to find my third number. And I get 6. Okay, then I can plug 4 in, and you get 12. And then you can plug 5 in, and you get 20. Okay, you're just doing the math. So now if I'm plugging 40 in, I'm doing 40 times 40 minus 1, or 40 times 39, right? I don't need to know the ones in front. I can just get my answer, which is 1,560. All right, so let's continue on, and let's go ahead and do some more stuff. We're going to flip back to page 2 and find our means. All right, so it tells us missing terms in an arithmetic or geometric sequence are called arithmetic or geometric means. Okay, means meaning the middle. Remember back in the day when you did proportions, you learned about your means and your extremes. The extremes were the numbers on the outside, the first numerator, the second denominator, and your means were the other two, the middle. So for something like this, when it's saying find the arithmetic mean, it's just saying, hey, find the average. That's something where you should be able to look at it and figure out, oh, duh, 16, it's in the middle. If not, add the 2 and divide by 2. No problem. Okay, but what happens when I'm asking you to find 3 missing numbers or 4? We don't want to have to sit there and keep averaging and averaging and averaging. While you can do that, there is another method, so let's take a look. I like to draw my blanks in here so that I know, make sure I'm accounting for everything. So I need to find out the 3 numbers that when I write in here, this will be perform a sequence, a pattern with a common difference. And I know it's common difference because it's telling me arithmetic. It gives me that info. So what we're going to do, guys, is we're going to use our explicit equation. Like you literally will be using that for so much stuff here. Okay, how? Here's our explicit. A sub n equals the first number plus the difference times n minus 1. Well, we don't know the common difference. That's what we want to find out. I want to find out what number I can add each time to fill in those blanks. So we're solving for D. That means everything else that I'm going to underline in red has to have a piece of information put in there. Well, we have all that info right here. Okay, so let's start with the first numbers 2. We don't know the common difference, so we're going to keep that as D. N minus 1. Well, how many numbers do we currently know? 1, 2, 3, 4, 5. And while I realize we don't know the middle 3, when we're done, we will. So we're looking at 5 numbers. So I'm going to make 5 my n. Now remember, these two things go in common. If I'm looking for the 5th number, I need to put what the actual 5th number is right here. It's the negative 22. And now I'm just going to solve for my common difference. Okay, so I've got 5 minus 1 is 4, so I've got 4d. I'm solving an equation. Subtract 2 on both sides, which leaves me negative 24. And so when I divide, my common difference is negative 6. So that's what I can add each time to go from 2 to negative 22 and have, 3 numbers in between. So when I add, I get negative 4, negative 10, negative 16, and make sure you do that last addition to make sure you're on track, and it works out perfect. All right, now we need to find 4 arithmetic means. So we're going to do the same exact thing. Negative 18, 4 blanks this time, 2, 3, 4 to 62. So I can once again set up that explicit formula to find my common difference to help fill them in. So negative 18 is where we started. We're trying to find our D. I've got 1, 2, 3, 4, 5, 6 numbers this time. So 6 minus 1. And that 6th number in the pattern is 62 because that's what I put in for my n. So that's why I need to fill back here for what that number is. So I've got 5d add 18 equals 80. And when you divide, you get 16. So that's my common difference. So now I'm going to use that and add 16. Negative 2, positive 14, 30, 46, and then add it again just to verify. And yes, it works out. Good. When it's saying the arithmetic mean saying, hey, find the one number. In this case, in all honesty, guys, I'm just finding the average. I'm going to just add those together and divide by 2. So it's 75. That's my middle number. You can use the explicit to set it up to find the common difference and add. The common difference is 72. 3 plus 72 is 75. Plus 72 is 147. But when it's only asking for one, just average it. We know how to do that. All right, so we're going to do the same thing for geometric down here. Okay, we're finding out what number we multiply by. So I can't simply add the 2 and divide because, wait, yes I can. That would work out. It's 20. Just kidding. Sorry. Add them together, you get 40. Divided by 2 is 20. My common, no, sorry, I can't. What am I doing? That would not be a common. That would be if it was an arithmetic sequence, not if it's a geometric. I apologize. Rewind. All right, so we want to use our explicit formula here. Okay, so we're finding 3 geometric means 1, 2, 3 blanks to 162. So same thing, set up your explicit formula. First number, we're trying to find the common ratio. I've got 1, 2, 3, 4, 5 terms, so 5 minus 1, and that equals the last term I have, 162. We spent time solving these equations earlier in the school year. Okay, so I can divide both sides by 2 because I want to isolate the variable. So I've got r to the 4th. I just did 5 minus 1 equals 81. Uh-oh, I've got something to the 4th power. What's the opposite of raising something to the 4th power? That's right, 4th rooting it. So when I take the 4th root of both sides, you get 3. That's my ratio. So when I multiply 6, 18, 54, and double check, and when you multiply, yes, it's 162. All right, so this one's asking me to find 2. So negative 18, 2 blanks, 9/4. Oh no, a fraction. Okay, so we set it up. Negative 18 times r to the 4 minus 1, which is 3, because there's 4 numbers here, equals 9/4. All right, guys, so when I divide both sides by negative 18, I'm doing 9/4 divided by negative 18, or I'm doing 9/4 times negative 1 over 18. Remember, dividing by numbers is the same as multiplying by the reciprocal. So I can reduce that by 1 to 2, so that's negative 1 over 8. Didn't even need a calculator. Okay, now when I third root each side, I get my ratio is negative 1/2. Negative 1/2 times negative 1/2 is a positive 1/4 times negative 1/2 is a negative 1/8. Okay, so I've got 9, negative 9/2, etc. Same thing, find the geometric mean you're looking for one number in between. Let you go ahead and do that one on your own. Just set up your explicit, find that. All right, moving on to page 5. So we're going to kind of go through just a couple of these together. The rest you can try on your own, and the answers are to the notes are posted. So I want you to go through and do them. I'm not going to do every problem because that would make this video super long, and I know you would all just skip it and not watch the end. I know you. So up here you can try these. It's just telling you which, find the 16th number, find the 21st number, use your explicit formula. Okay, you can do that. Check the work on the answer key. All right, let's take a look at, we're going to take a look at number 24. 23 is the same thing. All right, so it's telling us, I'm giving you the 4th term and I'm giving you the 9th term. Find the common difference. So this is, okay, well, what happens if you don't know the 1st term? That's okay. Here's what we're going to do. So the 4th number, 2, 3, 4th number is 16. 5, 6, 7, 8, 9th number 6. I'm asking you to find that common difference. Now, one like this, you could probably very easily figure it out in your noggin, but let's set up the steps to know how to do it in case you can't. We're still going to use that explicit formula, but for right now, we're going to pretend that these don't exist. We're going to pretend that this is a first number in our pattern, and we're going to pretend that, 1, 2, 3, 4, that this is a 6th number. 4, 5, 6, 7. Okay, good. Yep. Okay, so I'm going to use the same thing we just did, guys. First number 16, trying to find that common difference to the 6th number, n minus 1 equals 6. Okay, so I do the math and I get 5d equals negative 10. So I just subtracted both sides by 16. Divide and my common difference is negative 2. which you can go back and check. Subtract, subtract, subtract. Now the problem is asking me to write two formulas. So in order to do that, I do need to know the first term. So I didn't have that, but now that I know my common difference, if I'm going this way, I'm subtracting 2 each time. Okay. But if I'm working backwards, I'm going to add 2, right? 18, 20, 22. So now I know my first term. Now I know my common difference. So I can go ahead and write these two formulas. First term for recursive is 22. And then I write the line with the a sub n minus 1. And once again, refer to your formula sheet. Don't need to memorize this. And my explicit is first number times the common difference. I'm sorry, minus common difference times n minus 1. Right? Oops, that's supposed to be 2. Okay. So you can go back and try 23, same exact thing. So it's saying, hey, find that common difference. You don't know the first number, but treat what you do know as the first number, and you can work backwards from there. 25 and 26 are the same thing with geometric, guys. You can do these, okay? Same thing, just like before. Set up your explicit formula. All right, we're going to take a look at 2 more together, 2 word problems, and the rest will be for you to use as practice. So number 27 tells us if you had $145 in your bank account at the beginning of week 13 and $205 at the beginning of week 18, how much are you depositing weekly? Okay, what's it asking me for? It's asking for the common difference. So we're going to do the same thing as before. 145 is week 13. But for right now, we will treat it like week 1. We'll come back. And then 205 is week 18. So we got 14, 15, 16, 17. The blanks help me to make sure I'm counting the amount, my N is correct. You can set them up or you don't have to. All right, so from here, if I'm finding my common difference, I'm going to treat that like week 1, 2, 3, 4, 5, and 6, just to set that up. So I've got 145, trying to find my D, to the 6 minus 1 equals 205. Okay, so you do the math and you get 5 times D equals 60, which is 12. Okay, so that's the question. It's not asking how much I have in each week. It's not asking me how much I have total. It's saying how much are you depositing? It's ask for the common difference. It's $12. I mean, it's better than nothing, guys. At least you got a savings account going on. All right, let's take a look at one more together. Decide to open a savings account. Each week you're depositing $3 more than the previous week. The first week you're depositing $10. How much money will you deposit during the 25th week? So be careful here. It's not asking me how much money I have during the 25th week. It's saying how much are you putting in? So here's my common difference, and here's my A sub 1. Here's my N. What am I putting in on the 25th week? We'll take a look at to find the total in our next video. So my first week is 10. Common difference is 3, N is 25. So bada bing, bada boom, I do that math and it's $82. That's how much I deposited during the 25th week. Not how much is in there, it's how much I'm putting in. It's a good savings plan. Get started. All right, so I'm going to go ahead and I'm going to pause that video. You can do the rest on your own. It's great practice. Like I said, the answers are posted. You're more than welcome to come in with questions. Adios.